Hello and welcome back, everyone. Today we're going to be working on radical equations and problem solving. This is section 10.6. So this is going to have some similarity to the work we did on absolute value equations before. Just like at the start of an absolute value equation, the first thing we did was make sure that the absolute value was alone. Same thing here. If it's a radical equation, we want to get the radical alone and work our way from there. Some other similarities to other equations that we've solved before. Way back in chapter 7, we did end up having some solutions that were extraneous, solutions that worked for some of the steps a little bit further into the problem but didn't work in the original. Those can happen in here as well. Unlike the excluded value method that we used before, this one we just have to plug them in and check to see which ones work. So our instructions for all of the problems in this section are going to be solve, basically, unless stated otherwise. It's not going to tell you that you have to check that. It's going to, the author and quizzes and tests and such will assume that you know that you have to check them. So we'll start with square root of the quantity 3x minus 2 is worth 5. So the first thing is already done. The square root is by itself. It has its own side of the equal sign. So then we look at how to get rid of a square root. Well, if I square a square root, I am back to the original argument. And just like any other property of equality, if you do it to one side of the equation, you want to do it to the other side of the equation as well. So left-hand side, we now have a 3x minus 2. Right-hand side, we have a 25. If we create an extraneous solution, that is the step that actually does it, is squaring both sides. So this one turned into a linear equation in one variable, so we'll just add 2 to both sides. So 3x is worth 27, divide both sides by positive 3, and x is worth 9. Now, unlike most of our other problems, we cannot stop there. We have to check. So that is required. Don't forget that step. So we always check in the original problem. So all of your variables turn into parentheses. We keep all the other symbols the same, and we put a little equal sign or question mark above our equal sign. So our proposed solution is 9, and then we simplify each side until we have just one number per side and decide if it's true or false. So remember, any operations inside of a square root do count as grouping symbols. Now we move on to taking the square root. Square root of 25 is 5. 5 equals 5. Since that's true, we'll put a little circle around the x equals 9. We get to keep that in our solution set. All right, so next up, square root of the quantity 9x minus 2 minus 2x is equal to 0. So one major thing that I noticed that's different about this one from the others, or the other one we've done so far, the square root is not by itself. I have something else on that side that's not inside of our square root. That has to move, so I will add 2x to both sides. So then the square root of 9x minus 2, excuse me, is worth positive 2x. After that, after that, we can undo the square root by squaring both sides. So left side of 9x minus 2, right side 2x by 2x would give us a 4x squared. this one turned quadratic. Different strategy than the one that turned linear back here. If it's quadratic, we want to set one side to 0. Since our squared term had a positive coefficient in front of it, we'll go ahead and move everything to that side. So 0 is equal to 4x squared minus 9x plus 2. And that one we're just factoring by grouping. We're looking to multiply to positive 8, add to a negative 9, and negative 1, negative 8 will do both jobs just fine. So 4x squared minus 1x minus 8x plus 2, and factor by grouping. So I can pull an x from the first two terms. I can pull a negative 2 from the second two terms. So 4x minus 1 by x minus 2 is equal to 0. Multiplication problem ending in 0, set each side to 0 and solve. Either write the word or use the union symbol, your choice. So first one, I'll add 1 to both sides. 4x is 1, divide both sides by 4. X is 1/4, or add 2 to both sides. X is 2. So then we find out, do we get to keep one of them, or both of them, or neither one of them? We don't know until we plug it in. So this time we're going to have 2 checks since we have 2 possible solutions. So our first check, square root of 9 times 1/4 minus 2 times 1/4, possibly equal to 0. So we have square root of 9/4 minus 2 over 1 is the same as 8 over 4. Doubling a fourth, you're at a half. And we're seeing if we're equal to 0. So square root of 1/4 minus 1/2 is possibly equal to 0. Square root of 1 is 1, square root of 4 is 2, so a half minus a half possibly equals 0. 0 equals 0. So make sure you finish the check. So the 1/4 checks out, so we at least have one solution. Then we see if the 2 works out. That one's a little bit quicker since we don't have to work with our friends, the fractions. Let me see if I can squeeze it in here. So square root of 9 by 2 minus 2, minus 2 by 2, possibly equal to 0. So we have root 18 minus 2 minus 4, possibly equal to 0. Root 16 minus 4, possibly equal to 0. 4 minus 4, possibly equal to 0. 0 equals 0. So we got to keep both of them. 2 answers will satisfy that equation. Okay, so next up we'll play with a cube root problem. So we'll do the cube root of x minus 5 plus 2 is equal to 1. Again, unless we state otherwise in this section, they're telling us to solve. The radical is not by itself. Fix that before you do anything else. So we'll just subtract 2 on both sides. So the cube root of x minus 5 is equal to negative 1. Just like on doing square roots, we squared both sides. On doing cube roots, you guessed it, you will cube both sides. So left side in x minus 5, right side negative 1 times negative 1 times another negative 1. Multiply as many 1s as you want, you get a 1 back. Multiply 3 negatives, you stay negative. This guy was linear, so we'll just add 5 to both sides. So x is 4. So either we have the empty set or we have 4 for our solution. To find out which one, we check. So cube root of 4 minus 5 plus 2 is possibly equal to 1. So cube root of negative 1 plus 2 possibly equal to 1. Cube root of negative 1 is negative 1, so negative 1 plus 2 possibly equal to 1. 1 equals 1. That works out. We keep the 4. All right, so next up, we'll work back to square root problems. So square root of 9 plus x minus 3 is equal to x. So first things first, if the radical's not by itself, you've got to fix that. So I'll add 3 to both sides, and square root of 9 plus x is worth x plus 3. We're undoing a square root by squaring both sides. So left-hand side is now 9 plus x, right-hand side x plus 3 by x plus 3, and go ahead and FOIL that out. So we have a plus 3x, and a plus 9, and hit your like terms. This one, you can tell from the x squared, is quadratic. So we want to set one side to 0. Our square is positive, has a positive coefficient. So I'll move the 9 and the x. So now we have the equation 0 equals x squared plus 5x. 9 minus 9 is just a 0. This one's quadratic. It's already set to 0, so we get to factoring. So GCF of x by x plus 5. So either x equals 0 or x plus 5 is 0. First one's already solved. Second one, x could be negative 5. So we either keep one of them, both of them, or none of them. Find out which case it is, we've got to check. So I'll start by checking the 0. Square root of 9 plus 0 minus 3 possibly equal to 0. So grouping symbols first. Exponents and radicals next. No multiplication or division to worry about, so finish it off adding and subtracting. We've got at least one answer to this. 0 does work. We had 2 possibilities though, so we do need to do 2 checks. So square root of 9 plus negative 5 minus 3, my apologies there, minus 3 possibly equal to, and we're checking out a negative 5. So we have root 4 minus 3 possibly equal to negative 5. So grouping symbols first. Exponents and radicals after that. And negative 1 on one side, negative 5 on the other side, not equal to one another. So x equals negative 5 is an extraneous solution. It does not work in the original. So I'll put a little slash through the x equals negative 5 and a little circle around the x equals 0. That's the only answer from that one that will keep. All right. So next up, we look at a case where we have a pair of radicals. The square root of the quantity 3x plus 1 plus square root of 3x plus 1 is equal to 3. So first things first, I want to isolate a square root, a radical. Notice we have a couple of them. We just kind of pick one to get by itself. So arbitrarily, I'll just leave this one over here, which means I'll move the square root of 3x and the 1. So square root of the quantity 3x plus 1 is equal to 2 minus square root of 3x. We want to cancel that square root, so we will square both sides. So left side, we just have a nice, neat, pretty 3x plus 1. Right side, we'll go ahead and write it out twice so that we remember to FOIL. So hang on to the 3x plus 1, and FOILing out, we have 4 minus 2 root 3x minus another 2 root 3x. Negative times a negative is a positive, and root 3x times root 3x is 3x. All right, a little bit of simplifying to do there. 3x plus 1 is 4 minus 4 root 3x plus 3x. And we want to get the other radical by itself. So we got rid of one, now we get rid of the other. So I'll subtract 4 on both sides. I'll also subtract 3x on both sides. So negative 3 is equal to negative 4 times square root of 3x. I'll divide both sides by negative 4. Negative over negative is a positive, so 3/4 is the square root of 3x. Undo the square root by squaring both sides. So 9/16 is worth 3x. Divide both sides by 3. Dividing by 3, remember, is the same as multiplying by 1/3. So then our 9/3 is a 3. So 3/16 is our x value. So if there is a solution, this one's it. We don't know. Excuse me, we don't know for sure until we check. We always check in the original. So 3 by, there's our x, 3/16 instead. And got our plus 1 plus square root of 3, there's another x, 3/16 instead. Plus 1 is possibly equal to 3. Okay, so we've got some operations and grouping symbols to take care of. 3, if you want to think of it as 3 over 1, you can. So we have 9/16 plus 1 is the same as 16/16. Plus square root of 9/16 plus 1 is possibly worth 3. One more operation in grouping symbols to take care of. And then we can move on to exponents and radicals. So root 25 over 16 is 5/4. Root 9/16 is 3/4. And 1 is 4/4, as long as we're working with a bunch of 4s there. So 5 plus 3 plus 4 is 12. So 12/4 is possibly equal to 3. 3 equals 3. It does work out, so we get to keep our 3/16. Otherwise, we would have had the empty set. Okay, so some problems to try out from section 10.6. We'll try 1 to 21 odd, 27, 33, 37, 39, 51, 53, 61, and 69. All right, so if you have any questions, please feel free to get in touch with me via email. Otherwise, I will see you again soon. Stay safe out there.